Welcome, everyone. My name is Shakim, and I will be instructing you today in TypeScript for Beginners. This is a part of the complete series, and this particular video is for learning TypeScript in an hour or less. The purpose of this video is not to make you a TypeScript expert overnight, but it is to give you the foundational basics that can then take you to the next level as you continue to watch more courses. I'm the creator of amintech.io. That is my official website. And any code that I will be using in the lessons for this video will be linked in the description of the video to GitHub. So you can get all the code there. That way you can follow along. And if you make some mistakes, you have the raw code to actually go back and continue going throughout the course. So, what is TypeScript? Well, it is pretty self-explanatory. The word type refers to the data that we are writing as software engineers. So a lot of code is essentially nothing more than a bunch of numbers that are organized into specific structures. And so why was TypeScript created? Well, JavaScript is a dynamic programming language. What does that mean? It means that it changes all the time. So I could write a sentence and store it in a variable and then rename that variable with a different sentence in JavaScript. But that causes problems down the line, and we will discuss more about that in a later video. But for now, all you need to know is that TypeScript is a superset of JavaScript, and a superset just means that it's written on top of it. So your browser engine, the engine, let's say you're using Google Chrome, that browser has a V8 engine that only looks at JavaScript. It doesn't actually read or interpret any TypeScript. So TypeScript is a transpiled form of JavaScript. And once it's transpiled to JavaScript, then it can be read by an engine or phone. So this is a visual diagram of how a JavaScript engine works. A lot of times when people learn to code, they kind of skip over the fundamental parts of software engineering. So I'd like to always just do these basics for everybody, including myself. So your code, number one, it has to be parsed. Parsing just means it's being checked and making sure that it's following specific syntax rules. Then it is converted into a tree. Then that tree is then interpreted, and then after it is interpreted, it can be compiled and optimized. TypeScript assists you with this process by being aware of different types. You have a more defined program, and therefore you have a more defined understanding of what you're writing. And by default, the machine or the engine that's trying to interpret what you're writing, it understands what you're trying to write a lot better too. So the key thing that I want you to know about TypeScript, if this is something that's completely new to you, is that TypeScript was designed in mind to be written for large scale applications. Now, that doesn't mean that you have to have a large scale, multi-billion user application to use TypeScript. That's not what that means at all. It just means that TypeScript was written to be read and maintained on a very large scale. And that's why it's kind of distinct and separate from the JavaScript that a lot of us may be used to. So typical JavaScript has what we call prototypes, prototypical inheritance, dynamic types, and constructor functions. Recently, ES6 came along and changed a lot of the basic formats of how we used to write JavaScript. But TypeScript takes something a step further that, even ECMAScript does not do. It is strongly typed. It uses generics. It has interfaces, which is how we define objects and give types to properties on objects, and it compiles to JavaScript. So again, the browser cannot run TypeScript. Just for comparison's sake, just to give you a visual of the level of typing that you will find in many different programming paradigms, you'll see that JavaScript and C are much weaker when it comes to typing, and C is actually more static. JavaScript is more dynamic. But we have languages like Python, which have completely taken over the industry. We have Elixir, we have Ruby, we have Java, we have Rust, and we have C Sharp. So these languages are more strongly typed, which, the C Sharp and the Java and the Rust are more static, whereas the Python is a little more dynamic. So just a quick overview of variables and data types in JavaScript. So we have our primitive types, and primitive just means the most basic, smallest units of data that you can put into a computer. And what can be smaller than a number? So numbers, strings, and Boolean fall into primitive types. And we also have what we call null and undefined. Sometimes they're called trivial types. And we also have what we call composite types, and those are objects and arrays. And so essentially what I'm trying to show you here is that there's a difference between statically writing something and dynamically typing something. So we have an example of Java here at the top, which has a type on this variable called name. It says string name, then it says name equals John, and then the code here is trying to reassign the string name to 34, which is a number. And so this would cause an error in Java, and Java would say, hey, you're trying to assign a number to a string, and we cannot change the type of this variable. In JavaScript, however, not TypeScript, in JavaScript, we have dynamic typing. So we could create a variable called name, set it equal to John, and then change it to 34 because we have dynamic typing. Now, this caused a lot of errors as we develop code over time. We start to run into memory leaks. We start to have security problems. There's many different things that come from having dynamic typing. And so TypeScript is becoming one of the most widely adopted languages out there. I mean, it has over 24,525,000 weekly downloads. It is also used by over 4,219 companies, including Slack, Medium.com, Accenture, Stack, and Circle CI. So type safety is what makes TypeScript so special. And so one of the key questions of this introduction is, why do we need types? Why do they matter? And so we have to understand type safety, and then we will understand why types are so important. So type safe usually refers to languages that ensure that an operation is working on the right kind of data at some point before the operation is actually performed. This can be at compile time or at runtime. So, what is this really saying? It's saying before we actually run our program, our software, our code, our website, we make sure that it's actually going to do what we want it to do to the right data. So we don't want it to transform a string into, let's say, a number, which would then cause our program to fail at a certain point. And so the idea is well typed equals cannot go wrong. And so well typed is, again, it leads to a more well defined program. And that makes it a subset of all possible syntactically valid programs. And it makes your application more readable and more maintainable. And so continuing, just to show you some quick examples. So we just went over strings, we went over numbers, we went over basic data types, right? And so here's an example of how you can type an array in TypeScript. So var array1 is set to a number, and then we put the opening braces and the closing braces, and those mean that number, it is an array of numbers, and that's exactly what we have defined it as. We can also write this another way. We could say variable array2, array less than, greater than, number, and then set it equal to those values. And so I just wanted to show you guys just quickly what TypeScript looks like. There's also an any type in TypeScript, which essentially just means that instead of saying that you're creating an object of strings or an object of numbers or an array of numbers or an array of strings, you say, hey, I'm creating something and it could be anything. And so when a value is of a type any, you can access any properties of it, which in turn will be of type any. You can call it like a function, you can assign it to or from a value, or pretty much anything that's syntactically legal. So the any type is useful when you don't want to write out a long type just to convince TypeScript that a particular line of code is okay. Now, you usually want to avoid using any because you want TypeScript to be able to infer the types themselves. And so, yeah, any is not a best practice in TypeScript, but sometimes it can help you get things done very fast. And the key here is understanding the difference between implicit and explicit code. And so TypeScript has an inference system, which allows it to kind of infer if you are trying to do some sort of operation on a string, or if you're trying to do an operation on a Boolean or null value, it has that ability to infer based on the context, the lexical context of what you've written. So what I've showed in this slide is an example of a TypeScript component written in Angular. And even if you're not familiar with Angular, this is not an Angular course, but I just wanted to show you that if you understand types, you will still be able to understand what's going on here. So you see here that there's a class that has two properties, a myBool and a title, and the myBool is set to a Boolean type, and title is set to a Angular app type or a string type. And so even if you don't understand the framework Angular, just by being familiar with TypeScript, you will be able to understand what you're looking at. So real briefly, I wanted to talk about type annotations on variables. And so in Java, we have this type of syntax here where we have integer x equals 0. We don't write the type on the left in TypeScript. We actually write our type on the right. And so type annotations will always go after the thing that's being typed. In most cases, however, you don't even have to worry about this because TypeScript tries to automatically infer the types in your code. And so this isn't something you have to really even worry about too much, but I just wanted to introduce you to the concept of inference in TypeScript and how type annotations will always go after the thing being typed. So we have an example of a string, which is set equal to Alice, but we don't need to actually always specify that my name is a string because TypeScript is very smart and it will infer it itself. So that's just the key thing to take away from that slide. Here's a TypeScript cheat sheet, which I'll go over briefly. So number one, we need to understand the difference between a type and an interface. So interfaces can only describe object shapes. Interfaces can be extended by declaring it multiple times. In performance critical types, interface comparison checks can be faster. Think of types like variables. Much like how you can create variables with the same name in different scopes, a type has similar semantics. Build with utility types. TypeScript includes a lot of global types, which will help you do common tasks in the type system. Check the site for them. We also have what we call primitive types, which are useful for documentation mainly. So we have two examples, a type, which is a sanitized input, which is set to a string, and a type, which is called missing node, which is set to 404. So types are very good for documentation. And again, that goes back to readability. And also we have the object literal type, which is just we say type, we give it a name, and then we set it equal to an object. We have a tuple type, which is a special case array with known types as specific indexes. We will talk more about tuples in a minute. So really the key thing here is to take away the differences between types and interfaces, understanding object literal syntax, and also understanding union types. Those are the main things. You will run into map types from time to time, as well as conditional types. But for now, just take away a couple things and come back to this cheat sheet as you go through the course. Here's a quick React.js cheat sheet. For anybody that's not familiar with React, React is a JavaScript library for building user interfaces. And this guide targets React v15 to v16. And so you need to understand and be able to identify when you're looking at a component, which is a small part of code that, does something for your application. Properties are defined and passed in a particular pattern where, let's say you have a component called video, it has a property called full screen, and we can then set it equal to a child prop, which is called true. Okay, so this dot props is how it is written in older versions of React, but in modern React, we don't actually have to use the this keyword. Keep that in mind. Understand state and where to set state. Understand children and understand how to nest objects. So I'm going to show you an example of functional TypeScript right now. And so what we have here is a higher order function that takes an array and a function as arguments. So here's the array. It's an array and it's set to a type of a string of arrays. And then we have a function which is set to a type of filter function. And then we have a return type of an array of strings. And so here we have defined the type for our function. And we have said that it takes in a item, which is a string, and it implicitly returns a Boolean value. Then we have a new array which is set to a type of strings and is equal to an empty array. And for each item in our array, we want to add a new item onto our new array. And we are checking the name length of a name, and we are returning any name length that is greater than or equal to 10. We have a list that filters through these four values: Dr. 1, Dr. 2, Dr. 3, and Dr. 4, and then we output them to the console. So I want you to get used to seeing this functional programming context, because a lot of people that may have been coding before in JavaScript may not be familiar with functional programming as much as they are with object-oriented programming. So that is why I wanted to show you that. There's also some handy TypeScript built-in types. We have, of course, interfaces, which you will be using all the time in TypeScript, which is just giving types to your object. So all you're doing is creating an object, and you are giving types to the properties inside that object, to the shape of that object, I should say. Also, we have partials. And so partials allow us to make all props optional. Okay, this may be useful when you are using a component that has many built-in functionalities, many built-in properties, but you only maybe need, one or two. Omit syntax. These built-in types allow us to omit specific props. And so we will show you the value of this later on in this course. We also have parameters type, which gets the type of the function parameters. All right, so I just wanted to show you guys this little cheat sheet. Don't worry if you don't understand it. We will come back to it and we will explain it in more detail. Lastly, I wanted to show you guys an example of React code. We will be using React with TypeScript in this course. So what you're looking at is an interface called input props. It is extending a input HTML element attribute, and it is set to a type of an HTML input element. We have a name, which is a string, and a label, which is a string. We have a function, which is called input, and it is set to a functional component. It takes in these input props, which we gave a shape to here, and then we destructure name and label off of this object, and then we spread over all the remaining properties. We have a div, and we have a label and an input, and we pass in a label and input, a name, and all the rest of the properties there. So with TypeScript, it makes React way more readable. I mean, you get so much from this due to TypeScript that it really shows you the value of why TypeScript had to be created, because it's going to make your life a lot easier. So if this was a lot for you, don't worry. I didn't understand TypeScript at first when I first started learning it. But I'm telling you, over time, the more you're exposed to it and the more you work with it, the more you'll appreciate it. So that's all for the introduction to TypeScript. I will see you guys in the next part of the course. All right, guys, so welcome back to TypeScript for Beginners. If you have made it this far in the course, congratulations. Now you are about to get into the actual work of coming up with solutions to problems. So congratulations. So what I have set up for you is a repository on GitHub that contains 26 different lessons. Inside of each folder, we are going in order numerically, and there will also be two subfolders within each lesson. There will be a final folder, which will contain the final solution that you should expect to have at the end of every video. And there's also a starter file, which will provide the basic instructions of what you need to do for that lesson. So here, looking at starter.ts inside of lesson 1, TypeScript fundamentals, we see here that we are asked to create several variables, all right? So if you've never written code before, if you're brand new to this, don't worry. I'm going to take my time, but I'm also going to show you how to do things quickly and efficiently. So the very first thing that we're tasked with doing is creating a variable called my name and assigning it a string value. So how do we write variables in JavaScript? Well, we can write variables as constants like this. So let's create a constant and let's call it my name, and we can set it equal to John. Okay, we can also do let my real name and set it equal to Shakim. All right, now notice that we are getting an error message. All right, we did not actually say, is this a type string? Now with variables, we don't actually have to do this because it's inferred by TypeScript that we are creating strings. But for the sake of this course, I want to show you how to do it. So remember that we always write our types to the right after we declare our variable, our object, or whatever it is that we're trying to create. And so you can see here that I created two strings, stored them as variables, and I set them to type string with the values of John and Shakim. All right. Now we're going to create all of our variables with let for the sake of this course. So we're going to say let my name be set to a string, and we're going to set this equal to, let's just say 0303 2022. All right. So we just created a string. We just pass in a value that's a string. Next, we're going to create a variable called my age. And we're going to set this to type number, which is another primitive type. And we're going to set this equal to 44. Next, we're going to create a Boolean. And we're going to call it my Boolean. And we're going to set it equal to Boolean. And we're going to say that this Boolean is true. Next, we're going to create a variable called my height. And we're going to just set it to null. All right. And then we'll say equals null. All right. Next, we're going to create a variable called regx, which is going to be a regular expression type. So let's say let my regx set to type regx, and we're going to say / foo. All right. So what we've done just briefly in less than a minute is we've created 5 different variables, and we've set types to each of those variables: string, number, Boolean, null, and regular expression. Let's create something that's undefined. So let's say let my undefined be set to undefined and equal to undefined. All right. Next, we want to create an array of strings. And so there's 2 ways to create arrays. We can create arrays like this. So we can say let my array, set it equal to an array, and we can pass in a string, and we can set it equal to, let's say we want to call it Euphoria. We want to call it Power, and we want to call it Medea. All right. So this is how we declare array types in TypeScript. This is one way to do it. And there's also another way to do it. So we can also say, let my second array be set to an array of strings. And then I'm going to say the value of this array of strings is equal to Euphoria, Power, and Medea. So we can create arrays by explicitly calling them arrays, or we can simply write the type of values we expect in our array with these square brackets, and it will do the same exact thing. Next, we want to create an array of numbers. So let's say let number array, and let's set it equal to array less than, greater than number, and let's say equal to 1, 2, 3, 4, 5. Okay, so that is how we create an array of numbers. Now, what we want to do is we want to create a interface. All right, so this is an object. That's all the interface is. So we just use the interface keyword, and we're going to call this interface ID. And we don't have to set anything equal with an interface. We just use the open and the curly brackets, and we're going to give it 2 props. We're going to give it identification, which we're going to set to a number, and we're going to give it a passport, which we are going to set to a number as well. And so interfaces are how we shape our objects, and we pass those properties into our functions as interfaces and types. So let's actually just move that over. All right, and so let's actually write some more code. So next, sorry, let me fix this. That's better. So that's our interface. Now, we want to create a object that's going to have a type of ID. All right, and we're going to call it my ID. And right now we're giving it a type of ID. And so we're letting TypeScript know that we're going to assign some values to the types that are defined in this interface called ID. And that will then be passed in and will allow us to redistribute the interface all throughout our application. So let's set this equal curly brackets, and we are going to assign those two values to our identification property as well as our passport property. And so identification is set, and now passport is set. And now we have a ID, which is talking to an interface, and it is fully typed. So just briefly, to break away from the code for a second, let's think about how easy it is to read and understand what we're looking at. If we didn't have this type here, we would just be looking at identification and passport, and we wouldn't know that we're expecting two numbers to be passed into our function. So now what we're going to do next is create a record, okay, which will allow us to pass in multiple different types into one variable. So we're going to create a variable called identification record, and we're going to set it to a type of record, and it's going to take in a number and a string, and we're going to set it equal to an object, and we're going to pass in two values, 10, which is going to take in the string euphoria, and 20, which is going to take in the string power. All right, so records are very important because they allow us to pass in two types or even multiple types, combinations of types, and specifically records. And so our first type is here, 10. All right, and we have our second property, which is a string. All right, so with that being said, our last task for this particular video is to actually create a functional component in TypeScript. So what we're going to do is we're going to save all of those variables, but we're going to store them inside a function. So we're going to create a function called TypeScript basics, all right, which we're going to set equal to an arrow function. And TypeScript infers that we are trying to wrap these values inside of our function. So all we have to do is add a curly bracket there. All right, and next we have to return something from our functional component. And so what we're going to do is create a JSX fragment and render out a div with these properties. So after our identification record, we could just type in return, and we create a JSX fragment like so. And then we can pass in these values, these props, my name, my age, my Boolean, my height, my regex, my undefined, my array, and my number array, as well as my ID and my identification record. All right, so we have to close our return statement right there. And this will complete this video. So the last step to do is to actually export our function, which we're going to do there. Export default TypeScript basics. And we have, in just a few minutes, went through all the basic types. We went through regular expressions. We went through interfaces. We went through records, and we've also shown you how to destructure properties. So I hope you guys enjoyed this video, and I will see you in the next one. All right, guys, welcome back to TypeScript for Beginners, lesson number 2. In lesson number 2, we're going to talk about TypeScript functions. And of course, I've set it up already for you, so it already comes with several instructions. And I'm going to read those instructions to you, and then we're going to actually code this out. So we want to create about 1, 2, 3, 4, 5, about 6 functions. All right. The first function is called add number. And add number is going to be a function that has two number parameters that return the added value of the two numbers. The second function is going to be called add strings, which has two string parameters and returns the concatenated value of the two strings. We have another function called format that has two string parameters and returns a string with the first parameter and the second parameter. We will also create a function called print format that has two string parameters and prints the result of the format function, which is going to be a void function type. We also have a function which is going to be returning a promise that resolves to a string with the fetch data. We will also create a function called introduce that has a string parameter and any number of string parameters, and it will return a string with the first parameter and the concatenated string parameters, which is also an example of a REST parameter type. And we will import some of these files into our test folder. So I know that's a mouthful, but trust me, once you see what we're going to write, then you'll see like it's a lot more simpler and a lot less complicated than it sounds. All right. So let's begin. So we're going to go to our starter functions file, which we're in right now. And we're going to zoom in a little bit, not a whole lot. Let's make this a little smaller. All right. And so let's go ahead and start. So the first thing we want to do in this file is we want to create our add number function. So let's do that first. So let's go to that part of the course. So we're going to say export const, and we're going to say add numbers, and we're going to set it equal to two arguments. We're going to take in a number called num1, and we're going to take in another number called number, and we are expecting to return a number. And so that's what we're doing here. We're setting a return type. We're going to create an arrow function that's going to return these two values. And so what we're going to do is we're going to say return number 1 and number 2. We can also create the same thing with strings. So we're going to say export const add strings. And what we're going to do is we're going to set it equal to string 1, which is going to be a type of string. We're going to set it equal to also a parameter of string 2, which is going to take in a string, and we want to return a string. And so we're going to create an arrow function, which then is going to allow us to return concatenated values of these strings. And so we're going to say string 1, and then we're going to concatenate string 2. And there we go. All right. So now let's move on to the next one. And we want to say that we want to create a variable called export const format. And we want to pass in a title as a string and also a parameter as a string. And in this case, we want to say, well, what if we want our parameter to be able to be a string or a number? We can use what we call an optional. And so to do an optional, we typically write it like this if we're talking about or syntax, but it's not that. It's just one line, and then we can specify the other type we want it to be. We can then specify that this particular function needs to actually return void, or it needs to return a string, or it needs to return a number. So in this case, we could just say it needs to return a string, and then we can concatenate some values here. We can say, let's get the title, and let's get the parameter. All right, and so that is returning a type of string. So we can also, let's say we wanted to just print something. We didn't want to actually create anything, right? So let's just say we wanted to create something that just did a print. So let's say export const print format, and it's going to take in the same properties that we passed in before, but this time we're expecting it not to return anything. So we have set this function to a type of void. All right, that's all void means, is that the function doesn't return a value. So we can then console.log format, pass in title, and pass in parameter, and that will run every time we call print format. Now, let me show you how to add types to promises. So we're going to create a function or variable stored in a function stored in a variable called fetch data. And what we're going to do is it's going to take in a URL of string, and we are setting this to a value of a promise, right, which is going to take in a string. And then we want it to actually return a string. So we're going to write an arrow function, and then we're going to say we want to resolve this promise and say resolve all the loaded data from this particular URL. All right, and that is how we add types to promises. And lastly, what I want to show you guys is how to use REST parameters. And so what we're going to do is we're going to create a function called introduction. And introduction is going to take in a salutation, which is going to be set to a type of string. And then we're going to use REST parameters. We're going to spread over an array of strings called names. And then we're going to set the return type to a string. And so what we're going to do is just return salutation, and we're going to join all the names together with the join method. All right. So I know this may have seemed like a lot, but all we're really doing is setting types to our parameters. That's the key thing there. We are setting types to our return types. So we know what we're expecting and we know what we're putting in. We know that we're expecting a string here. We know that we're expecting some array with a bunch of strings in it. We know that we're setting this to a promise, or we're trying to resolve a promise. We've set up what we're putting in and also what we're expecting back. So with that being said, I hope you enjoyed this introduction to TypeScript functions, and I will see you in the next video. All right, you guys, welcome back to TypeScript for Beginners lesson number 3. And in this lesson, we have several instructions here inside of our function starter TS file. We want to create a function called print a file that takes a file name as a string and a callback function as parameters. We want to also create a function called mutate array that takes an array of points and a mutate function which takes a value number and returns a number. Remember that callbacks return void. We want to create a type for that mutate array, mutate function, and pass it in as a parameter to mutate array. We want to also create a new function called adder function that takes a number and returns a function that takes a number and returns a number as well. We want to also create an adder function clone and a new variable called add1. So I know that sounded like a mouthful, but let's write this code. So let's start with our print to file function. So we're going to say export function print to file. And again, it's going to take in a file name with a string, and it's going to also take in a callback, which is going to be typed as a function that returns void. Next, we're going to set our return type to void, and then use our object syntax. And in this function, it's not returning anything. It's just logging whatever file name we give it and calling our callback. So that is our print to file function. Next, we want to create a function called mutate array, and it's going to take in an array of points, and this array called points is going to be filled with numbers, so we're going to set it to a type of number array. Next, we're going to create a function called mutate, and we want that function to essentially return some values. So we want it to take in a value called number, number, and we want it to return a number. All right. And next we're going to say we need to return a number for our return type. And what we want to do is just map over our points. Okay. Now we can actually make this a lot more efficient. And this is where types and interfaces come in. So Instead of writing that our function mutate needs to take in a number and return a number, we can literally just cut and paste this into a type. And so we're going to create our very first type, and we're going to call it mutate function type. And we're going to set it equal to a value number that returns a number. And so now we can actually get rid of this and change this to mutate function. Okay, so that is how we pass in types to functions, or specifically our mutate function. Next, I want to show you guys the adder function. So for the adder function, we're going to do the same thing. We're going to give it a type first. So we're going to say type adder function. And actually, we don't need the mutate there. We just need that. All right, and so type adder function is going to take in a value, which is going to be a number, and is going to return a number. And actually, this doesn't have colon syntax. This should just be equal. All right, next, let's create our adder function clone. And so let's say export default function, adder function clone. And it's going to take in a number called num. And we're going to say that it needs to return type adder function. And then we're going to return a value, which is going to be set to a type of number, and is going to return the combination of the number value and the value. And lastly, we're going to create a function called add1, and we're just going to call adder function. Adder function. And then we're going to pass in a number. Let's just pass in 200, or we can pass in 1. We can pass in any number we want because it's expecting a value, which is going to be a number. And then we're going to console.log. We're going to call add1, and then we're going to pass in a number of 55. All right. And so just that fast, we learned how to type functions with functions. And in our next video, I'm going to show you how to do some more things with functions so you can make them more readable and easier to read. So I will see you guys in the next video. All right, guys, welcome back to another Typescript for Beginners course. In this lesson, lesson number 4, we're going to be learning about function overloading. So what is function overloading? Function overloading is allowing you to essentially pass in more values to functions so that you don't have to write more code. That's essentially all it means. You overload the function with extra values so you can then pass those values, extend those values to other parts of your application. And a lot of JavaScript is actually functions inside of functions inside of functions. So function overloading is definitely an essential tool when it comes to being great at JavaScript. So let's get started actually with some code for this lesson. So again, this is lesson 4. And what we're going to do, you see we have some instructions here that say we need to create an interface called a coordinate. And remember that interfaces and types are just objects, okay? And it's going to have 2 numbers, x and y, as properties. We're going to also create a function called parse coordinate from object that takes an object with x and y properties and returns an object. We're going to create a function called parse coordinate from numbers that takes 2 numbers and returns an object with x and y properties. We will also have a demonstrated example of how to use function overloading with parse coordinate. We're going to make our return type coordinate. We're going to coerce the arguments. We're going to make the second argument optional and write some if and else statements based on whatever type we've assigned to our arg1 or our arg2. We will also console.log parse coordinate with an x and y value. Now again, that sounds like a lot of work, but it's actually not a whole lot of work. So now let's begin. Okay, so what we want to do is we want to create our interface first. So we're going to say interface coordinate. And remember, interfaces don't require any equal signs. It's just an object. And it has 2 values, an x, which is a number type, and we have a y. number type. Okay. Next, we're going to create a function called parse coordinate from object. And it's going to take in a object, which we're going to give a type of coordinate to, which is coming from our interface. Okay. Next, we're going to set our return type also to coordinate because that's what we want back. And then we're going to say return, and we're just going to spread over our object and just return our object right here, which we passed in. Okay, very simple. Now let's create a parse coordinate from number function. So let's say parse coordinate from numbers, and we're going to pass in two numbers, a x with a type of number and a y with a type of number. And we're going to set our return type to a coordinate. And so here we're just expecting to get back x and to get back y. Very simple. All right. Next, we're going to create a parse coordinate object, just a parse coordinate function. And this is where we're going to get into the function overloading. So function parse coordinate is going to take in an object called coordinate, and it's just going to have a return type of coordinate. Okay. Now, we're going to show you how to overload this function. So let's say you wanted to add some more properties to this function. You wanted to add some different type of arguments to this function. You wanted to extend this function and make it do more. So let's create the function with the same name. We're going to call it function parse coordinate. And it's going to take in two arguments. For now, we're going to call them unknown, because we're going to say, well, we don't know what we're passing in. We don't know we're passing in a string, a number, a Boolean. We're not going to worry about that right now. So you can also give properties and parameters unknown types as well, in addition to the typical number, string, object, etc. So what we're going to do next is we're going to set our return type to coordinate, and then we're going to create our object, and then we're going to create our coordinate object. So we're going to say let coord. We're going to set it to a type of coordinate, and then we're going to set it equal to x, and we're going to give them both x and y initial values of 0. Now we've initiated our coordinate object. Now we're going to say if our argument is equal to a object, then we want to spread over the values of argument 1 in our coordinate and return it. So we're going to spread over argument 1, and we're going to use the as keyword to say, well, as you're executing this code, we want you to look at argument 1, not as unknown, but as a coordinate. Okay? Now we've given our function, which just took in a coordinate and returned a coordinate, more flexibility. Okay? So that's what function overloading is. It's giving your function more power, more capabilities, more methods. Now we want to say, well, if it's not an object, let's see if it's a string. So let's say else if type of arg1 equal to a number. Let's see if that's what it is. And if it is that, then we want to say arg1 as a string. We want to split that string and then for each value in the string, so we say for each, we can say value, and then we want to return a key and a value. And then we want to split at the colon, and that's where we want to break the values apart. Okay. Next, we can say coordinate key as key of coordinate is equal to whatever value we parse. All right, so this is the same exact thing as saying this. So we could also say chord key as X or Y. These are called union types right here. Each equal to a parse integer value. So this is the same thing. You can write a union type, which is kind of like the or symbol, or you can say as. Okay, so those are the two main ways that we coerce types in TypeScript for now. All right. And lastly, we want to write one more else statement, and we want to say else set the coordinate to, set the coordinates to, sorry, hold on. X is going to be an argument 1 as a number, and then Y is going to also be as a number. Okay, and then we just cancel that log. I don't know why that array is there. So we just cancel that log, parse coordinate, the object with the value x1 and y2. So what this video was intended to show you is how to overload functions, how to take them from, very dry, very bare bone object type return types to actually coercing types and checking the types of the parameters that are passed in. So I hope you enjoyed this video, and I will see you in the next one.